Okay, for this lesson, we are going to tackle the problems involving quadratic equations. So how are we going to apply the concepts and its solutions in problem solving? So we are going to have here an example. A rectangle is 30 centimeters long and 20 centimeters wide. A rectangular strip is added to one side and another of the same width to the other side, resulting now in doubling the area. So find the width of the strip. So how are we going to attack the problem? So we are going to make an illustration and label the illustration with what are given. Okay, so we have a rectangle whose length is 30 centimeters and whose width is 20 centimeters. Okay, so it is also mentioned here that there is a strip that is added to one side. So we are going to add a strip, rectangular strip on one side of our rectangle and the same strip with the same width on the other side. So this is now the strip that is added to both sides of our rectangle. Okay, so how are we going to solve the problem? So let's try to recall the area of the rectangle, area for the rectangle. So area now of your rectangle is equal to the length times your width. Okay? So we are going to identify first the area of the original triangle, or rectangle rather. So we have here the area is equal to length times your width. So simplifying that by substituting the length, which is your 30 centimeter, by your 20 centimeter. So this would give us an area of 600 centimeter square. So this is the original area, or the area of the original rectangle. Now, let's try to consider also the bigger triangle by which a strip was added. Since we do not know the width of the rectangle that is added, so we represent that as our x. And this is also the same as x. So we have now a new length for our rectangle, so which is now your x plus 30 centimeter. And on the other side, our width now is your 20 plus your x, or simply your x plus 20 centimeters. So that is now the bigger rectangle when we added the strip on both sides. So we have now your area is equal to your length this time is your x plus your 30 centimeter, and the width now is equal to your x plus your 20 centimeter. But as mentioned a while ago, this would result to doubling your area. So there is already your times 2. So if we are going to have now your 2 multiplied by what is the original area, that is your 600 centimeters square, this is equal to your x plus 30 centimeter multiplied by your x plus 20 centimeter. So we have to simplify. So this is 1,200 centimeters square. And then on the right side, we are going to apply the FOIL. What does the FOIL stands for? Okay, so we multiply the first and the first term. So x times x would give us x squared. O stands for the outer and the outer term. So x times your 20 would give us 20x centimeter. Okay? And the inner times the inner. So this would give us your 30x centimeter. And then we have the last and the last. That is your L. That would be 30 centimeter times 20 centimeter will give us 600 centimeter square. Let's combine similar terms. So these are the same. Okay? So we are going to bring your 1,200 to the other side. So what is left here is your 0. That is by subtraction property of equality. So we have now your x squared plus 20 x centimeter plus 30 x centimeter would give us 50 x centimeter plus your 600 centimeter square. Your 1,200, since we subtracted both sides, your 1,200 giving us 0 here would also be subtracted on the other side. So minus 1,200 centimeter square. So therefore, we have now your x squared plus your 50x centimeter. What is 600 minus 1,200? So this would become 600 centimeter square. So to come up with the value of our x, let's apply what we have learned when we were in your grade 9. So there are 4 methods of solving your quadratic equation. So this is already your quadratic equation. So this is your factor out, your x squared. So this would be your x times your x. How about the factors of negative 600 that would give an arithmetic sum of 50? So take note, this is positive. So let's say positive 60 times negative 10 centimeter. Okay? So your 60 minus 10 will give you 50. And 60 times negative 10 is negative 600. Therefore, your factors are correct. Apply the zero product property. So therefore, we have x plus your 60 centimeter is equal to 0. And at the same time, your x minus 10 centimeter is also equal to 0. So if we come up now with the value of our x, so this would become, your x is a negative 60 centimeter. On the other side, x now is equal to positive 10 centimeter. Since we are dealing with dimensions, okay, there is no negative dimension. So what are we going to do with the negative value of your x? So we are going to reject. Okay? And how about the value of x that is positive? This is the one that we are going to accept. Therefore, what is our x a while ago? X now is equal to the width of our strip. Okay, that we are looking for. Okay, if we want to check the answer, if we substitute your x with 10, and your x also here with 10. So we have 10 plus 30 is already 40. And x plus 20 is 30. So what is 40 times 30? That would give us now an area of 1,200 centimeter square. Okay? So this is the solution of problem number 1. Okay? So we apply the solution of your quadratic equation. That is by factoring. So the method that we apply here is by factoring. Okay? Yan. So let's have another problem. Still a geometric problem wherein we are going to come up with the solutions of your quadratic equations as applied in your geometric problem. Okay, so this time, let's have the second problem. So we have here 2 bikers started at the same corner. So one going to the east, and the other going to the north. One biker was traveling 3 kilometers per hour faster than the other. After an hour, the two bikers are already 15 kilometers apart. So what we are going to look for, we are going to find the speed of each of the biker. Okay? So this is our problem. So we are going to illustrate first our problem. So we have here as the corner where they have started, one biker is going to the north and the other is going to the east. So this is your north and this is your east. So let's say this is traveling at X speed and this is traveling at 3 kilometers per hour plus your X because it is 3 kilometers per hour faster than the other. After an hour, so here is the location of the first biker after an hour, and this is also the location of the second biker after an hour. So the distance between them after an hour is already 15 kilometers. So the problem is, what is the speed of the first biker and what is also the speed of the second biker? So let's solve this one. If we try to take a look at our equation or illustration rather, this represents a right triangle. And we know that in your right triangle, we are going to apply the Pythagorean theorem. Okay? So, I suppose you have already discussed your Pythagorean theorem in your grade A. So, this is advocated by Pythagoras that has something to do with right triangles. And what does the Pythagorean theorem tells us? In any right triangle, the square of the hypotenuse is equal to the sum of the square of the legs of your right triangle, and the legs are the altitude and the base. So, in our illustration, 15 kilometers here would be our hypotenuse. Our x is our altitude. It is vertical. And our base is your 3 kilometers plus your x. And that is our base. So substituting in our formula for the Pythagorean theorem, so this is your C. So we are going to have your 15 kilometers per hour square is equal to, our altitude is x. We need to square that, plus we need to square also your base, which is your 3 kilometers per hour plus your x. Okay? So, this is now your Pythagorean theorem. Simplifying, what is 15 squared? That is your 225 kilometers per hour square. Okay? Is equal to your x squared plus, this is the square of a binomial. So how are we going to square a binomial? Okay, so this is a special product. You need to square the first term. So 3 squared would be 9 kilometers per hour square. Then the middle term would be 3 times your x. So that would be your 3 kilometers per hour x. But what are we going to do? We are going to twice the result. And then square the last term, and that would give us your x squared. So simplifying further, this is now your 225 kilometers per hour square is equal to your x squared plus x squared would be your 2x squared plus your 2 times 3 is equal to your 6 kilometers per hour times your x, and this is now your 9 kilometers per hour square. Okay? So, This is similar to your last term. So we are going to add the 2. Okay? So we are going to apply subtraction property of equality. We subtract both sides, your 225, so this will become 0. So this is your 2x squared plus your 6 kilometers per hour x plus your 9 kilometers per hour square minus 225 kilometers per hour square. So this would give us your 2x squared, of course here is your 0, plus your 6 kilometers per hour times your x. Subtract your 225 with your 9. So what is 225 minus 9? So this would be negative 216 kilometers per hour square. Okay, so we are going to apply your factoring. Or would you like to use your quadratic formula? So it is also applicable. So but notice that your 2, your 6, and your 216 are divisible by 2. So we are going to reduce by dividing all our terms by 2. Okay? So this is now your 0. This is now your x squared. This is now your 3 kilometers per hour times your x. And this is your negative 108 kilometers per hour squared. Okay, so by factoring, let's factor out. So we have your x times your x. What are the possible factors of 108 that will give us a positive 3 arithmetic sum? So what would be? So let's say positive. So what are the possible factors of negative 108 and your positive 3? Rather, factors of 108 that would give us a positive 3 difference. So let's say 12 times your negative 9. Okay? KPH and KPH also on the other side. So let's say 12 times your 9, so that is 18, carry 1, so that is 9, 108. Okay? Correct. So 12 minus 9 will give us your positive 3. Now, we are going to equate each factor to 0. That's what we have done a while ago. So we have your x plus your 12 kilometers per hour is equal to 0. And the other one is x minus 9 kilometers per hour is equal to 0. So your x here would be positive, becomes negative 12 kilometers per hour. On the other side, your x is equal to 9 kilometers per hour. If you try to take a look at the first value of your x, it is a negative. Do we have a negative speed? So, there is no negative speed. So, what we are going to do here is, we are going to reject. On the other side, our speed is positive 9 kilometers per hour. So, we are going to accept this one. So, therefore, going back to our illustration, this is our x. So, this is the speed of the biker going to the north. So, 9 kilometers per hour. How about the other biker? So, if we are going to have our 3 kilometers plus x, so this would be 3 kilometers per hour plus the value of x that we have obtained there is your 9 kilometers per hour. And this would give us a 12 kilometers per hour. And this is the speed of the second biker. Okay? So if we are going to check our answer, simplifying that, we have our A is 9 square, substitute, plus your B is 12 square. So that would give us 81 plus 12 square is 144. and that would give us a sum of 225. If we are going to extract the square root of 225, this would give us your 15, which is the hypotenuse of your triangle, and this is now the distance between the two bikers after 1 hour. So it means we arrive at exactly 15, and this is also 15, so it means the computed value, the computed speed of the first biker as well as that of the second biker are both correct. Okay, so that's all for this time. Thank you.